Good morning, student. Today we are going to discuss the next idea called prime factorization. We are going to discuss the next idea called prime factorization. Prime factorization. See, when we are discussing in the last class, we discussed some prime numbers and we discussed how to find the prime numbers using Euler's formula, using Escott's formula, using Fermat's formula. We discussed how to find the prime numbers using Euler's formula, Escott's formula and Fermat's formula. Now, today we are going to discuss some applications. We are going to discuss some application. When we discussed in the last class, what we said, we gave some sample prime numbers. What are all the prime numbers? We said 2, 3, 5, 7, 11, 13, 17, 19 and so on. We said the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19 and so on. Now we are going to use this prime number. We are going to use this prime number and express the composite number. Express a composite number as prime numbers. As prime numbers. We are going to express a composite number as prime numbers. What is this dear? For example, let me take an example. Express as prime factors. Express as prime factors. I am going to take the number 504. I am going to take a number 504. What is the meaning of this? What is the meaning of this? I am going to take the number. I am going to divide this number by the least prime number. I am going to divide this number by least prime number. What is the least prime number? We know that very well. The least prime number is 2. So I am going to divide the number by 2. So when we divide 504 divided by 2, what will be the answer? This is 252. 252. We are going to divide 50 by 2. So the divisor, when we divide, though the answer is 252. I am going to check this again. Shall we divide this number by 2? Shall we divide this number by 2 again? So this will be 126. So this is 126. Now again I can divide this number by 2. So what we are going to do now, we are going to keep dividing the given number. We are going to keep dividing the given number until we reach the last number, until we find the last number as 1. So again I am going to divide this number by 6. This is 2, this is 63. Isn't it? This is 63. Now I am going to check this. I cannot divide this number by 2. I am going to check the next prime number. What is the next prime number? 3. What is the next prime number? 3. I am going to divide 63 by 3. This is 21. 63 by 3. This is 21. Again I am going to divide this number by 3. Again I am going to divide this number by 3. So what will be the answer? This is 7. 7 is a prime number, so I can divide 7 only by 7. So the number is 1. The number is 1. Now I am going to write 504 in terms of prime numbers. I am going to express 504 in terms of prime numbers. So how I can write? This is equal to 2 multiply 2 multiply 2 multiply 3 multiply 3 multiply 7, isn't it? So this is 2 multiply 2 multiply 2 multiply 3 multiply 3 multiply 7. So how I can represent this? This is 2, 1, 2, 3, 3 times, so 2 power 3. Multiply 3, 2 times, so this is 3 power 2. And 7, 1 time, so this is 7 power 1. I am going to write the number 504 in terms of prime factors. When I check here, I am having 3 2, so this is 2 power 3. I am having 3 2 times, so this is 3 power 2. I am having 7 1 time, so this is 7 power 1. So the basic idea of prime factorization, we are going to take the number and we are going to keep dividing the number by prime numbers. We are going to keep dividing the numbers by prime numbers until we get the last number as 1. And then we are going to represent them in the powers of prime numbers, and we are going to represent the numbers in powers of prime numbers. Understand the idea now? Let me discuss one more problem so that may be easy for you. Express as prime factors. 1026. So I am going to take the number 1026. I am going to check by the least prime number. I am going to divide by the least prime number. What is the least prime number? 2 is the least prime number. So when I divide, this is 513, isn't it? 5 times, 1 time and 3 times. I am going to check this. We cannot divide by 2. So next I am going to check the next prime number. What is the next prime number? We can divide by 3, because 5 plus 1, 6 plus 3, 9. This is divisible by 3. That means I am going to divide by 3. What will be the answer? This is 1 time. This is 7 times and 1 time. 171. Again I am going to divide this number by 3. We will keep dividing the number until we get the last number as 1. I am going to divide this number by 3. So this is 5 times 15 and this is 7 times 21. 5 times 57. Again I can divide this number by 3. What will be this? This is 19. 19 is a prime number. So I am going to divide 19 by 19. The answer is 1. So now how I can write 1026? I am having 2 multiply 3 multiply 3 multiply 3 multiply 19. Correct? 2 multiply 3 multiply 3 multiply 3 3 multiply 3 multiply 3 multiply 19. So this is equal to 2 1 time 2 power 1, 3 times 3 power 3, 19 1 times, so 19 power 1. So what we are having? We are having 2 1 time, 3 times, 19 1 time. This is called prime factorization. We are going to take the number, we are going to divide the number by prime numbers. And then we are going to represent the composite number in the multiplication of prime numbers. This is called prime factorization. In the next video, we are going to discuss some applications on prime factors.